Here we go. So in the last class, we're actually looking at the systems with internal heat generation. And in this class, we'll look at a problem in that continuation to what we have seen in the last class. Okay, so let me take both the problems now. So this is what in this. The first question we have already seen, and the second question let us see now. From here onwards, let us see. Okay. This is our question now. See, in the previous question, both surfaces are maintained at 150 degrees centigrade. Now, in this case, it is 130 degrees centigrade and 150 degrees centigrade that is given in question. And on left and right sides is given. So if I have to represent it here, it's like this. Here it is 130 degrees centigrade. On the other side, it is 150 degrees centigrade. And the thickness is given as 12 centimeters, the previous question itself. And the Q value, L value are given. The L value means 6 centimeters, that is 12 by 2 is given. And Q value, K value is given. See, if this is the case, what you have to do. Okay. See, from now onwards, what we are going to do is we are going to use the data book for solving this kind of problems. Okay. So I hope most of you have your data books with you, and this data book is allowed in the examination also. But for now, what I'm going to do is I'm going to show you the data book here so that it will be easy for us this in this online class. But strictly speaking, no, you should have a data book with you, and then this data book you have to use in your exam also. Okay, so can you see it? Is it visible to you now? Is the letters visible to you? Somebody please confirm if they're able to see the letters here. The letters are not clear to you? Hello? Am I audible?
Yes, sir. Yes, sir.
Are the letters visible to you on
No,
your
sir.
screen, or
Can
I
you
have
zoom?
to I'll increase the size? Now I think it's better.
Yes, sir.
Okay, so what you have to do is for solving this problems, you have to move to this page number 56. Page number 56 and 57 you have to use. Okay, the problem that we have solved yesterday can also be seen here. Okay, this is the um, this is the formula that we have used yesterday. Okay, this formula we have used, this formula we have used, this formula we have used. Okay, so using these three formulas we have solved in the last class. Okay, the same way today what we are going to do is we are going to use the appropriate case here. Here the first case is in symmetry case. Okay, and the second case is actually cylinder case that we will see later. But now what we have seen is our problem is it's an asymmetric boundary condition. Okay, this is the case for asymmetric boundary condition, and these are the formula for your asymmetric boundary condition. So using the formula that are given here, you may solve this particular problem. Okay, so yeah, so let's move to the formula, move to the problem. So in the problem, what is giving you is giving you, let me change my view. This is a bit difficult for me. Yeah. Now let's look at this problem. In this problem, what is given is asking you to find out what is the location. Is asking what is the location of the maximum temperature. Is asking. So what you have to find is you have to find out what is the x value. You have to find out. Okay, x max you have to find out. For finding the x max, here you can see on my right side of the screen. Here I cannot write actually, but you can see the formula there. Okay, the formula is visible to you. The x max formula, if I write there, I'm writing the x max formula here. This is equal to k by 2ql into tw2 minus tw1. So you have k value. With q it is 200 given in question, and the q value is 10 to the power of 6 given in question, and the L value is 6 centimeters. 6 into 10 to the power of minus 2 have to take, and then tw2 is the temperature on this side, that is tw2 is 150. This is tw1. On this side it is 130 degrees centigrade. So what you have to do is you have to write 150 minus 130. You have to write here. So that's it. So somebody tell me what is the value of this one.
0.033 meters.
0.033 meters. Okay. So that is your x max he is asking you to find in the question. And what else he is asking you to find? He is asking you to find the value of maximum temperature. Okay. So how to find out this value of the maximum temperature? Again, you have to refer to the appropriate formula that are there. Okay. So here for T max, you have a formula. Okay. So I'm zooming it to you. So the T max formula you can see now. So I'm writing the T max formula here. The T max is equal to Q dot into L square by 2K plus K by 8Q into L square. Q dot meaning Q gen. Okay. Q dot meaning Q gen into TW1 minus TW2 whole square plus half TW1 plus TW2. Okay. Now you substitute all the values here. The Q dot is 10 to the power of 6, and the L is 6 centimeters. 6 into 10 to the power of minus 2. The K value is 200 plus the K value is again 200 by 8 into the Q dot is 10 to the power of 6 into the L square is 6 into 10 to the power of minus 2 whole square into TW1 TW1 minus TW2. Let me write it as 150 minus 130 whole square plus half of 150 plus 130 whole square. Okay. See, check with this values here, the values of 150 and 130, whether they are taken in degree centigrade or Kelvin, it matters to you. Okay. In this case, now it is a difference whether degree centigrade or in this case whether degree centigrade or Kelvin doesn't matter. Whereas here you made an addition, so you may have to check whether these values are correct or not. Okay. For that, what you have to do is you have to refer to your nomenclature here clearly. Okay. So here, whatever the values that are given to you, TW1, TW2, as you can see, their surface temperature in degree centigrade itself. So you can substitute the values in degree centigrade itself. Okay. So that's the thing, right? Um, yeah. Somebody please calculate and tell me what is this T max value.
Sir, is it 151?
Yeah, it is
7.
151.77 degrees centigrade. So that will be your T max. Okay. Um, right. What else is asking you to find in the question? Value of the maximum temperature you have found out and the location you have found out. Also find the heat flow on each side and the temperature at the center plane. First, let us find out the heat flow on each side. Okay. So how to find out this heat flow on each side? See, for heat flow, do you have any formula here? See, for Q, you don't have any formula here. So you have to do it on your own. You can observe here, you don't have any formula for Q. So you have to do it on your own. So how to do it? So Q he is asking you to find, and he is asking you to find it on both sides. On 130 degree centigrade side you have to find out, and on 150 degree centigrade also you have to find it out. So how do you do that? Yes. See, for that what you have to do is you have to look at the location of X first. Okay. Once you understand what is the location of X, then you will be in position to find out this Q. Okay. See, the temperature curve here can be, it can be like this. Okay. Here on this side it is 130 degrees centigrade. On this side it is 150 degrees centigrade as given in the question. You have just found out what is T max. Okay. This is T max being 151 degrees centigrade, and you will also have something called as X here. Okay. How did you get the X? Okay. See, if you look at your uh, if you look at this diagram, see X he is starting from the center. Okay. X he is starting from the center. So from the center, this is your X. So what is this position of X? This position of X is, you have found out that the X max is equal to 0.033. So this is what you have found out just now. So if you have this value with you, you will be in position to find out what is Q. How you can find out is, see, the Q value is given in 10 to the power of 6 watt per meter cube is given to you. And if you multiply it with some meter, no, it will become a watt per meter square. Okay, it will convert into watt per meter square. So what I'll do is I will multiply this 10 to the power of I'll multiply this 10 to the power of 6 with 0.033 or appropriate x value I will multiply here. Okay, so you have to multiply that. If it is for 130 degree centigrade side, what should I multiply it with? I should multiply it with this much of the distance. Okay, that distance will be, this is 6 centimeters on this side, that is 0.06 meters, and on this side it is 0.033. So if I add it together, what I get here is 0.0933. So what I can put here is 0.0933 meters. This meter goes, meter square remains. So what you get Q on 130 degree centigrade will be equal to so many watt per meter square. Somebody tell me what is this value? This simple multiplication.
93300.
93300.0 you get. Okay, that is on the uh, that is on the 130 degree centigrade side. Q on 150 degree centigrade side, if you have to find out, what you should do, you have to multiply the 10 to the power of 6, that is watt per meter cube, with this distance. Okay, that is, let me show it with the red color. This one. What is this one? It is 0.06 minus 0.033. Okay. So what is this value? 0.06 minus 0.033. Okay. It is in meter. This one goes. Square will remain. So we will get the answer in watt per meter square, and Q on 150 degree centigrade side will be equal to, tell me the value, 10 to the power of 6 into this.
27000.
2, 7,
27000.
000 or 0 watt per meter square. Is it? So this is the Q on both sides. If you want Q total, it is not asked in the question, I'm just telling you. You have to add these two. Okay, 93300 plus 27300. You'll get the Q total in so many watt per meter square. No? That's how you find the Q value. Apart from Q, what is asking you to find? Is also asking you to find heat flow on each side. You have found out the temperature on the center plane. Temperature on the center plane he is asking. Okay, so temperature on the center plane means what? Temperature at x is equal to 0. What is the value he is asking you to find? Okay, so for that, do you have any formula here? See, if you look at the first formula, the first formula is corresponding to this. Okay. When Tx is equal to 0, you can put in the first formula and find out what is the value. Okay, so if I have to write Tx, the Tx is equal to q by this q dot by 2k into L square minus x square plus x by 2L into TW2 minus TW1 plus half TW1 plus TW2. So that's what we write from the data book. Okay, all these things we are getting from the data book only. Keep that in mind, right? So what is x here? X is equal to 0 because you want it at the center plane. At the center plane, the x is equal to 0. And then you know everything else actually. So you can simply substitute t at x is equal to 0 is equal to q standard power of 6
149.
by. You are asking what? Yeah,
Tx
it is
equal
1.
to
It is 1.2 into 200. The L square value is 6 into 10 to the power of minus 2 whole square minus 0 plus this whole thing will become 0. 0 by 2L into TW2 minus TW1. I'm not writing this because this whole term is 0. Half 150 plus 130. So this value will be 149 degrees centigrade. So T at x is equal to 0 will be 149 degrees centigrade. Okay, these are the values. This is one thing he's asking you to find. The other thing is this thing. And this one. This is T max. X max. So whatever he's asking you to find, you have found out using the data book. I hope it is clear how to use the data book to you. Okay. So if data book usage is not clear to you, please ask me. I'll clarify upon that. So we'll move to the next problem. Okay, it will be a little bit quick compared to this one. So where is that? Here it is. Right here you have a wall of thickness. (40 mm) and its surfaces are maintained at 0 degrees and 100 degrees centigrade. The heat generation is this one 3.25 into 10 to the power of 5 watt per meter cube. The thermal conductivity is 2 watt per meter. Kelvin determine the temperature at the mid plane. Location temperature at the mid plane. T at x is equal to 0. What is it? He is asking. And what is x? He is asking. And T max is asking. Okay. It is again a simple thing. You have to use the appropriate formula, substitute it. Okay. So let me write the formula for T at x is equal to 0 now. Okay. T at x is equal to 0 is equal to. See, this is from data book anyways. It is good to write what is the page number also. From the data book, the page number is 56. See, keep writing this because if you don't have page numbers with you while referring to your notes, it will be of no use to you. Okay. So the page numbers are very important. Please keep writing the page numbers. Even if I miss, you remind me, I will write it for you. This is the formula for x is equal to 0, temperature at x is equal to 0. It is 3.25 into 10 to the power of 5 by 2 into 2 into the L value is 0.02 in the question, minus 0 square plus 0. This whole thing will become 0. I'm not writing the remaining thing. Half of 0 plus 100. Substitute and get this value. So T at x is equal to 0.
51
What is
band
it?
51 band 3 degrees.
51.3 degrees centigrade. Let me check it. Meanwhile, you keep solving the other things that are asked in the question also. It is not 51.3, I guess.
82.5.
Sir,
82 point.
82.5.
It is 82.5.
Sir, is X
This
max 0.015?
what?
X max, sir.
Yeah, you're right. X max is correct. So for finding X max, what I have to do? I have to use this formula. The formula for X max is again from data book. Okay, keep writing page number 56. What I get is X max is equal to K by 2 QL into TW2 minus TW1. The K value is 2 given in question, 2 into 3.25 into 10 to the power of 5 into the L. L is 0.02 and TW1 minus TW2 is 100 minus 0. So you'll get what is X max. What is that? 0.013 meters. So that's what X max is. And then what is he asking? He's asking T max. T max is equal to Q into L square by 2K plus K Q dot. Q dot it should be L square into TW1 minus TW2 whole square plus half of TW1 plus TW. Now the Q dot is 3.25 into 10 to the power of 5 into the L square is 0.02 whole square
Sir, is
by,
it 101.7?
yeah, correct. The
Oh,
K value is 2 plus 2 by 8 into 3.25 into 10 to the power of 5 into the L square is 0.02 whole square into the TW1 is 100 minus 0 whole into minus 0 whole square plus half of 100 plus 0. So the value will be T max will be equal to 101.74 degrees centigrade. Degrees centigrade. It's asking me to find this, and we also ask me to find the X max and T at x is equal to 0. Okay, we have found out whatever is asking me to find. I hope it is clear to you how to use the data book and all.